The goal of the white bell hook is to attract traders from centralized exchanges. So we want to make limit orders as close and as functional as possible as on centralized exchanges. White belt is just a reference to martial arts. On centralized exchanges, you can place your limit order on a single tick price, and there will be a guaranteed price of execution under the condition that the mid price crosses user's limit order. Funds are immediately available after the trade. Historically, on decentralized exchanges, before Uniswap v2, you had to add liquidity over a range from 0 to plus infinity. Now, since Uniswap v3, you can add liquidity on a smaller range, and this range has to have a size higher than 2 ticks. So we will use this feature, we will add liquidity over only 2 ticks. We started from the template provided at lesson 6, but there are a few discrepancies. First, when the user adds liquidity, the liquidity, instead of slipping in the pools manager, it will be added as liquidity on the market. Then, once a swap is crossing the liquidity of the user, and the liquidity of the user goes from bid to ask or ask to bid, depending on the direction of the trade, we immediately cancel it, instead of, in lesson 6, triggering more trades. Triggering more trades actually would provoke trades in cascade on the pool, especially on big limits like 100k US dollar for Bitcoin, which will trigger actually price instability. And the user won't have the price guaranteed as on our limit order. We chose a trade-off in the way we coded the functions. When we add the order, there will be more gas for the user willing to add liquidity because it will add its order in a sorted list. However, after swap, when a swapper swaps, there will be less gas for him or her because the lists are already sorted and the algorithm is simplified. So more gas actually for the user wishing to add liquidity, less gas for the swapper. The workflow is as simple as on centralized exchanges. You first add the order, then you can cancel it if you want, or it gets executed, and then you can redeem your funds. Okay, so let's dig into the code. Here is a place limit order function taking into account the price of the limit order, the direction of the trade, and the wished amount to trade. Here in the first lines of the code, we check that everything is coherent. Mid price, limit order price, and the direction of the trade. Then here we get the minimal range on which we will add liquidity. Here we add the liquidity on this minimal range. We add the inputted amount. Then, for accounting reason, we take the tick price, which is the furthest away from the mid price, and then we do our internal accounting. Here, I want just to emphasize that we used a sorted structure linked list that will be useful in the after swap function. Here is a cancel limit order function, which is just the reversed function of adding an order, so I won't spend too much time on it. Everything was tested here in these 3 tests: test place sell order, test place buy order, test cancel limit order. Here are the hook permissions. We just use the after swap permissions, and we will just process the direction of the trade and the mid price after the swap. In the process orders after swap function, we just check if the ending mid price after the swap has crossed the best bid or the best asks that we stored. And then, depending on that, we cancel the according liquidity that is then redeemable by the user. Here is a quick estimation of gas. So here we have the lesson 6 gas usage. Here we have the white bell hook gas usage. So before the swap, when we place an order or if we cancel, we use more gas in the white bell hook than in the lesson 6. However, after swap, we need to make a subtraction of either this one by that one, or this one by that one, or that one by that one. And we see that we use much less gas than in lesson 6. So we respected the trade-off we wanted to do in terms of gas usage for the limit order users instead of the swapper.